All right, lesson 2 of our triangle unit. So if you're with us in class, we did a little opening activity, um, how to deal with our lesson today. If you're joining us online for participation and note sheet points, we are starting on page 6 of our packet. And basically, again, our unit is on triangles, and we talked about how the word triangle itself, tri means 3. So if we have 3 angles and we extend their sides and their arms and have them hold hands, we do in fact get a triangle. So triangles, no matter what they look like, if it is a triangle, if we measured all of their angles and we added them up, we're going to find that no matter what shape our triangle, or not what shape, but what size or what, specific type of triangle it is, our angle measurements, when we add them up, are going to equal 180 degrees. So taking a look at the first 2 examples here, again, we know 2 out of the 3 measurements, so we're able to take that idea that all of them inside have to equal 180 and able to figure that out, this last missing measurement out. So again, if all of them add up to 180, grab a calculator here, we could start with that value of 180 and take away the 2 measurements that we do know. So again, we know 54 and we know 67. So we start with 180, we subtract 54, and then subtract 67, and we're left over with 59. So 59 is that missing measurement right here. And we could work backwards just to double check, right? If we added all of these up, we should also get the value of 180 if we did it correctly. So let me just show you that real quick in our calculator. Again, if I took all those measurements, 59 plus 54 plus 67, I do get that 180. So 59 is correct. So 59 degrees. All right, taking a look at example B, same idea. I know 2 out of the 3 measurements, so I would start with 180 and subtract what I do know to figure out what is this missing angle in the bottom corner there. So 180, we're going to subtract 50, subtract another 35, and we find that that measurement there is 95. Same idea, I could add all 3 of these measurements up, and I would find that it's equaling 180. All right, so if we take a look at example E, we're kind of jumping down. We skipped a few problems there in the middle. But E has, the same idea, but just a little extra to it. So again, I know actually 2 out of the 3 measurements, we have 30 degrees up here. We actually do know the measurement value of this given this symbol. If you remember, guys, this is a right angle symbol. So right angles are 90 degrees. So if it helps you to sketch that in there before you start calculating, by all means do. So again, I know 2 out of 3. I want to figure out this third angle. So we take 180 and we subtract what we know. So minus 30, minus 90, and you find that that missing value, this angle right here, is 60 degrees. All right, sometimes we have to do a little extra digging. So if I'm looking at my triangle here, let's go to example C. And again, this is in your note sheet, page 6. Here's my triangle. Again, I know that all of the angles inside there have to equal 180 degrees. However, I only know 1 out of the 3. If I only know 1 out of the 3, I really can't, kind of just start with my subtraction rule there. But if you notice, I do have outside information, right? I have this angle right here that says 85. And if I look at how that angle is created, you should notice that it's created by 2 straight lines. And we learned that when we have 2 straight lines that cross, we create what we know as vertical angles, meaning that opposites, verticals are those opposite angles. And we learned that the relationship between opposite angles is congruent. They're equal to each other. So if this guy up here is 85 degrees, then right below him, the opposite is also 85 degrees. So right here, 85 degrees. So that's my measurement for X. Now that I've used that, I do, if I look again at my red triangle there, I now know 2 of those values. So I could go ahead and subtract from 180. So 180 is the total of that red triangle. We're going to take away 55. We're going to take away 85 that we've just discovered for there at the top. And I get my last measurement there of 40. So this guy down here would be 40 degrees. Again, if I added them all up, 55, 85, and 40, you would find that they all equal 180 degrees. All right, take a look at example D. So again, if I start by, looking at my triangle here, you should notice I can't just start off with subtracting from 180 because I only know 1 out of 3. So extra information, you should see it there, is that I have this 65 degrees here. Now this time, if I look at how that angle is put together, I have a straight line, okay, and then I have kind of this this other angle line here. And if you notice, 65 is closest to y. Its relationship there is that it creates a linear pair. There's that line on the bottom. It makes a rainbow, it makes a protractor. We talked about it several different ways. But the relationship here is they're not equal, but they're equal to 180 because it creates a half of a circle. So we could start out by saying, okay, 180, and we're going to take away 65 to figure out what that other angle measurement is, and it's 115. And guys, I always want you to kind of think logically. This is an obtuse angle, right? So it should be larger than 90 degrees. 90 degrees is that straight, perfect L, right? And it is larger than that, so 115 does make sense. So that's going to be our value of y. Then from there, looking at my triangle, that kind of pinkish triangle, I now know two of those measurements. So I am going to follow that idea that, again, measurements inside a triangle are 180 degrees. I know 28, so we're going to subtract that, and then I also know 115, and it leaves 37 degrees for this top. 37. Oh, that's a little hard to read there. So this is 37. So our value of x is 37. So again, just as a quick recap, again, all of the angles in a triangle are 180 degrees. If you know 2 out of 3, you can just go ahead and start subtracting from 180. Sometimes you'll have symbols in there, like this 90 degrees, that although it's not a number, you know the measurement of that value. And then you do have those the additional information type problems where we've got our triangle, but there's some outlining information that helps us kind of figure out 2 out of the 3 so that we can go ahead and subtract. Okay, one more here. I didn't realize there's an F. So let's take a look at it. Here's my triangle. I know that my x and y are inside, and that's what I'm trying to find, the value of x and the measurement of angle y. So looking at my triangle, I only know 1 out of 3. I can't do anything right away. Using outsider information, you should hopefully see here that I do have angle 30 up here, which is created by these two straight lines, which tell us these are vertical angles. Vertical angles are the same measurement. So for x, it's 30 degrees. Once we know that, we've got 2 of the 3 measurements, so we could go ahead and steal our calculator here. Take 180, that's our measurement of all 3 put together. We're going to take away 30, take away 80, and we end up with 100 degrees. Oh, sorry, actually, subtract another 30 there. So we end up with 70 degrees. That would be my y value. So again, 30 plus 70 plus 80 does indeed give you 180. All right, taking a look at rule 2. So the acute angles of a right triangle. Remember, we talked about a right triangle has the symbol right here. So this is our right angle. The other 2 angles are acute angles, and they're complementary, meaning 90 degrees is taken up right here, and these other 2 measurements are equaling 90. So the 2 smaller angles are added together and set equal to 90. So in this example, I have variables, but I know the relationship and can help set up an equation and solve. So we have 2x plus 3x. We're going to add those 2 smaller angles together, set them equal to 90. Combine like terms here on the left, 2x and 3x makes 5x, equal 90. Divide by 5 so that we can solve. And you should see there it does tell you that x equals 18. So then if we were actually going to figure out the measurements, we would go back and substitute. So if x is 18, over here we have 2 times 18, which is going to give us a value of 36. And then over here, 3 times 18, let me grab a calculator. 3 times 18 is going to give us the angle measurement of 54. So we could use the idea of that relationship to set up an equation, solve for a variable, plug it back in so that we're able to tell what our angle measurements are. All right, so to set up the equation, again, here's my right angle. We're going to add the 2 smaller angles and set them equal to 90. So we have x plus 2x and is equal to 90. From there, solving, x's together, equal 90, divide by 3 to get x all by itself. So x is going to be 30. That means in our problem here, this is 30 because it is just an x variable. And over here on the right-hand one, we have two x's, so 2 times 30 is 60. So we have a 30, 60, and again, this box means 90 degrees. Right here, if we're looking, again, this box right here tells us this is 90 degrees. The other two, if I add them together, again, are complementary, equaling 90. So we add 4x and 30 equaling 90. This problem is a two-step equation. We cannot combine any like terms. And working our way through solving this equation, x is going to equal 15. So plugging that in, we already know this one's 30, and so this is 4 times 15, which in a sense is going to give us back to 60. So 60, 30, 90. Again, same kind of triangle, same measurement, set up a little bit differently. But again, the rule still applies, that we're adding those two smaller angles and setting them equal to 90. So for this last one, again, here's my right triangle. We know that's 90. That means we have 90 left to share between those two. So adding them up, x and 47 gives us 90. Solving that equation, we would subtract 47 from both sides. 90 minus 47, 43. So we know x is 43. Going back and applying it to my problem here, again, x we said is 43, this guy's 47, and this is 90. And again, if I add them all up, we do get 180 degrees. All right, so last rule here, we'll cover it quickly, is that the measure of each angle in an equilateral triangle, remember equilateral triangles are where all sides are the same. So the angle measurements in equilateral triangle are 60 degrees. So what is the value of x in each of the triangles pictured below? So 60, 60, kind of the same. This is equilateral triangle. We see our hash marks. Sorry, I forgot to add those, guys. So we know automatically, hey, it's got to be 60. You may not have realized it's an equilateral triangle, and that same idea that 180 degrees is the entire triangle, we could have also looked at this problem and subtract our 60 in there. Subtract 60 again and end up with a 60. So either method there works. For this bottom one, again, equilateral triangle, all sides are the same. So in this case, we know all of our angle measurements are equal to 60. So check this one's 60. Check this one's 60. This one should also be 60. So knowing that, you could set up an equation and solve for x. So 2x is equal to 60. Solving through, we see multiplying, so we divide to get x by itself. And x would be 30. Now you may be like, what? You just told me it was 60. Remember, my variable is 30. So when I go to apply it, 2x's, 2 times 30, does give us that 60-degree measurement overall. So those are basic 3 rules when you're trying to figure out angle measurements within a triangle. The most common and the most important one that you remember is that angles within a triangle all add up and equal to 180 degrees. So there is an independent assignment of this activity. Check Canvas, check your box. I'll tell you in class if you're present, but this does give you note sheets and participation points. So good luck. Thanks.